All right, so I'm going to go over the answers for the review sheet here. And on this first page, I just wanted to give you kind of like a topic list of things. Now, it might seem like a lot, but a lot of these things are from Algebra 2. Um, you know, Practically everything you see here was touched on in Algebra 2, and so there's a little bit like review slash a couple new things. So don't be too worried. All right, so let's do this first one here. So this right here is a quadratic function, a parabola, and normally a quadratic function would be right in the center here. So normally it would be, sorry, I lost my little fancy pen. I'm going to turn my screen this way so it's a little bit better and I'm just more used to that view there. So normally a parabola would be like right here in the center, and so you notice this was moved to the left 3 and down 4, and so that's what I'm talking about in those transformations. So I would move left 3 and down 4. So that's my new vertex. And so, that's a good thing to note on your graph, -3, -4. Over here, this is on the right side, and it's also going to infinity, so you could label that. And this is on the left side, and it's also going to infinity. So those are kind of like the x and the y values of the arrows in a way, if you can think of it like that. Okay, so what's the equation? And so you can use Desmos if you want to put all these in, but once you know it's left 3 and down 4, oh no, I made a mistake. So I was changing my picture. I meant this to be letter D right here. This should be a 4, and that should be a 4 right there. These should be 4s right here. So to kind of confuse the issue, sorry about that. But the answer should be letter D, and I'm going to change that on my copy that I give to you. Anyway, my domain. So remember, my domain is the width of my graph. Also, what you could do for your domain is you could look at your x values. You have this x value, this one, and this one. So the smallest x value is -infinity, and the biggest is +infinity. So basically all real numbers. All right, and the range. So the range are the y values. So if you look at those y values, the smallest one is -4, the biggest is infinity. So I'm going to put -4 to infinity. Or it's also the height of your problem. So remember, this is the width, and this one's your height. All right, the x-intercepts and y-intercepts. All right, so the x-intercepts, I see them at -5 and -1, so I'm going to put -5, 0, and -1, 0. And the y-intercept is right there at 0, 5. Something to notice. Intervals of increase and decrease. So remember, increasing and decreasing. When something has a positive slope, it's increasing. When something has a negative slope, it's decreasing. All right, so if you're trying to compare that here, if I look for the increasing section of this graph, I would say it's this whole right side of the graph right here. This whole right side, all the way over there. So if I try to name that area, I would have to name it. It starts at -3 and it goes off to infinity. So that is the increasing section of my graph. -3 to infinity. Because remember, we use the x values on increasing and decreasing intervals. And then the other part's decreasing, the left side. So this part's increasing, this part's decreasing. And so that's from -infinity to -3. Okay. All right, now the end behavior, we already have it on our arrows up there. When x is infinity, so when I look over here as x is infinity, then the y value is also infinity. And when x is -infinity, right there, then the y value, f of x, is infinity. So I'm just going to go ahead and put those two answers. And also, both ends are going up, so I mean, that should make sense. All right, next problem. Given this function below, there are 3 points labeled with their coordinates. So those are these points right here. Okay, place a star on the absolute maximum point. So absolute maximum, that would be this guy over here. He is the tallest place on the whole graph. Place a smiley face on the relative maximum point. So this guy, 4, 1, is a relative maximum because he is not the tallest or the biggest place, the biggest y value, but he's pretty high for his area. And the relative minimum point is this other one. We're going to put a heart on that one because that is a low place for its area, but it's not the lowest on the whole graph because the graph has to go down forever. All right, the decreasing intervals. So the decreasing sections, let's see, this part here has a negative slope and this part here has a negative slope. So remember, we're going to contain those with the x values. So the green part here goes from, let's see, -3 to, let's see, that's 1 over here. So -3 to 1. Also, another decreasing area would be 4, and this goes off to infinity on the right-hand side. So 4 to infinity are the decreasing intervals. In interval notation, what's the range? So this graph goes low forever, so that's negative infinity, and the highest it goes is 4. So 4 to negative infinity. So I would put negative infinity first, and then 4, bracket on the 4, because it touches 4, and parentheses there. All right, last problem here on this page. Given these two functions, find these two things, f of h of x. So remember, if I'm doing f of h of x, f is the boss. So I'm going to write down 4 something plus 7. And in that blank space, I'm going to put, in that x space, I'm going to put h of x. So 3x squared minus 2x. All right, so now all I have to do is multiply that out. So I get 12x squared when I distribute. Then I get minus 8x, and then I have plus 7, and I'm done because those don't go together. All right, h of f of negative 1. So the easiest thing to do here is to go ahead and figure out the answer to this first. So I'm going to do that. So f of negative 1 would be 4 times negative 1 plus 7. So that would give me 3 as an answer. All right, so now I want to find h of that 3 because now I figured out the green part is 3, so I'm going to do that. So 3 and then 3 squared minus 2 times 3. So that would be 9 times 3, so 27 minus 6, so that would be 21. Okay, doke. All right, so next page. So using the graph below, answer the following. So f of negative 4. So I'm going to go to negative 4 on the x-axis. I'm going to go up to my graph, and there it is at 1. So I'm going to go ahead and put a 1 here. F of 0. So I'm going to go to 0 and look for my graph. Well, there it is down there. So I would say negative 3. Now f of negative 1. So negative 1 is that place, and you knew I would ask you, should I go up top or should I go down below? Well, I should go down here because this is like a little ghost place right here. It's not really there. So negative 2. All right, is this a function? I would say yes. If you draw vertical lines everywhere, it passes a vertical line test. Even right here, it only crosses right there. So it passes a vertical line test everywhere. What type of discontinuity is at negative 1? X equals negative 1. So this right here is a jump discontinuity. Imagine if you were, driving a car along, you'd have to jump to get down here and go across. Okay, so it's a jump discontinuity. Remember those three, there's jump, there's infinite, and there is removable. All right, let's fill in the equation for this. So I have given you this problem right here. This is y equals 1, and this is y equals x squared minus 3. I have given you these two functions in my problem right here. So I basically just want you to fill in what the boundaries are. All right, so this y equals 1 part is going from negative 1 back, but it's not including the negative 1 because there's an open circle. So right here, I would put for all x's less than negative 1. And for this section right here, I would put for all x's greater than or equal to negative 1, because that graph starts when x is negative 1, and it just keeps going that way. Okay. All right, so now like we practiced in class, we're going to graph this piecewise function. So notice over here, it's 2. 2 is the place. Right here on the graph, it's going to be changing from one graph to another. So I'm just going to graph each one, and then I'm going to erase the part that I don't want. All right, so 2x minus 1. So if I had 2x minus 1, I would start at negative 1 and go up 2 over 1, and so I would get this graph. So you might want to wait a second, or you graph this in pencil. Okay, so I want this graph for everything less than or equal to 2. So when x is equal to 2, there's my graph. So I basically want the left side of this. So I'm going to get my little eraser, and I'm going to erase this other part. I don't want it. Okay, and then I want this other graph. This other graph says x plus 3 when x is greater than 2. So x plus 3 would start at 3 and go up 1 over 1. And I want this graph whenever x is greater than 2. So that means I don't want the part that is before 2. So I'm going to erase it right up to there. And I'm actually going to erase that point also because I need to go and put an open circle right there. Okay, and there you have it. That's it. Desmos can also help you out with that. All right, use this rational function picture to answer some questions. So this line going across here, this would be y equals 1. That's a horizontal asymptote. This one going up and down, this is x equals 2. This is a vertical asymptote, remember? All right, interval notation. What's the domain? So it's touching everything except 2. So I would say the domain is negative infinity to 2, or from 2 to infinity. What's the equation of the vertical asymptote? Well, there you go, x equals 2. All right, let's see, letter C. What's the type of discontinuity? So that would be an infinite discontinuity. Okay, what's the equation of the horizontal asymptote? Well, we talked about that, y equals 1. And so when you have a horizontal asymptote, this is the thing that your graph approaches as you go far to the right and far to the left. So this question is asking as x goes to infinity. So that means as you go off to infinity this way, what does your graph do? Well, my graph kind of calms down and becomes 1. And when I go to negative infinity this way, my graph comes up to it, but it still stays at the 1 level, like almost, like just below it, but basically at 1. So we say 1 for both of those. So whenever something has a horizontal asymptote, that's what happens. All right, and last little bit right here. Interval notation, what's the domain of this function? So you could help yourself out a lot here by doing a graph. You can go to Desmos and do that, or you just know that this is a square root function. So normally square root functions are right in the center, but this one's moved to the right 3. So there it is, and it's over to the right. Oh my gosh, all these meeting invites. Jeez Louise. All right, sorry, it's stressing me out. So the domain here is everything from 3 over, including 3. So I'm going to say 3 to infinity. That's the width of my graph, and bracket. I could also do this. I know that everything inside a radical, x minus 3, has to be greater than 0, and it could actually equal 0 as well. So when I solve that, I get that x is greater than or equal to 3, which is exactly what that means. Okay. Number 14, what's the domain of this guy? So I've been telling you over and over again, when you have a fraction, you have to worry about that denominator never equaling 0. So hopefully in your mind right now, you know that you could never use negative 5. So x can never be negative 5. So in interval notation, you would say negative infinity to negative 5, don't include it, or negative 5 to infinity, and don't include the negative 5. So that right there means everything but 5, negative 5 in interval notation. All right, these two functions right here. I want to know if they're inverses or not. So we need to inspect a little bit. So this one over here on the left has the point 2, 0, and I need to check is 0, 2. Yep, there it is. Let me find another one like 6, 2. So 6, 2 should produce 2, 6, and there it is again. So, I had to draw this on the computer, so this one up here is like not that great, but I intended them to be inverses of each other, so you just have to go with the flow there. All right, this other guy right here, if I start checking, 0, 3 would have to turn into 3, 0, but I don't see that there. This was 0, negative 3. That is a big no. And let me see if I finish before my pencil dies. All right, given this function, find f negative 1 of x. So that means find the inverse. This notation here means inverse. Okay, so that means right now this is y equals x to the third plus 5. I'm going to switch the letters. So I'm going to make this x equals y to the third plus 5. I got to move the 5 over. So I get x minus 5 equals y to the third. Then hopefully you remember that to get rid of a cube, I do a cube root. All right, so then that would mean I would have y equals cube root of x minus 5. And there's my inverse. But it was given to me in this f of x notation, so I'm going to write f negative 1 of x equals cube root of x minus 5. And that would be my answer. Okay? All right, for number 17, I do want you to find the inverse function, but first let's talk about the domain and range. This right here is a square root function. It's moved up 7. So that's why the domain is everything to the right of 0. That's why I put that, and that's why the range is everything 7 and above, because this is the point 0, 7, and that kind of begins my problem. So first of all, know that when you do the inverse, the domain and range just flip-flop, because you're switching the x's and the y's, right? So the domain is now 7 to infinity, and the range is now 0 to infinity. Okay, so let's go ahead and find that. So normally this problem is y equals radical x plus 7, so now I'm going to make it x equals radical y plus 7. So I'm going to go ahead and take away 7, so I get x minus 7 equals y. And then I am going to, oops, I forgot my radical, still there. And so now to get rid of a square root, I'm going to square both sides. All right, so my answer would be y equals x minus 7 squared. So I'm going to go ahead and put x minus 7 squared in there. All right, let's see, letter A. Given these two functions, find the following. So this letter A means subtraction. So I'm just going to take f of x and subtract g of x. So I have x squared minus 4x minus 2x. And so I have x squared minus 6x is my final answer. All right, f of x over g of x, so I'm going to take x squared minus 4x and place it over 2x. Now, like we went over in class, also I want the domain of this. So looking at this problem now, you know the denominator could never be 0, so I would never let x be 0. So my domain, I'm going to say all real numbers, x can never be 0. But I do notice that all 3 of these pieces have x's. So you can do it by factoring or just by knowing that everything has an x. So if you cancel an x out from everybody, you would get x minus 4 over 2, and that would be your final answer for f of x over g of x. All right, and this last one means multiply. So this just means f of x times g of x. So I'm going to do x squared minus 4x, and I'll multiply that by 2x. It looks a little bit backwards, but all we're going to do is distribute right here. So when I do that, I get, let's see, 2x to the third minus 8x squared, and that will be my answer. All right, my last little question for you. Complete these sentences. Even functions are symmetrical over the, so let me draw you an even function. An even function would look something like this, kind of like a parabola is an even function. And do you see how they're symmetrical over this line right here? So that would be the y-axis. All right, and then an odd function. So an odd function would be something like, let's say we look at this guy right here. So do you see that everything on the right side of the origin, so everything here has its reverse over there. So it's like opposite answers. So this has symmetry about the origin right here. If you took everything and rotated it 180 degrees, it would turn into the other side. So we call this symmetrical about the origin. Okay, and that is it.